Ready? Shh. Yep. It's crazy important that you pay attention because we have to make sure we understand how to do this. So I know you're like, well, we just did adding and subtracting. How different can it be, right? Because if I take 5a is equal to 20 and I solve it, I just divide. I remember how to do this, Ms. Z. Why do you need to do a whole set of notes? A is equal to 4, right? Now, with equations, they don't ask you to graph your solution because your graph sure wouldn't look like much, would it? If it was an equation, you would put a circle, you'd color it in, and you'd be done. Because what are all the numbers that A can equal? 4. It's the only number that when I take it and I plug it back in and multiply it by 5, I get 20. It's the only number, okay? But we're not talking about equations. We're talking about inequalities. So if I take 5a is less than or equal to 20, but I solve it the same way, and instead of an equal sign, I put my less than or equal sign, I have a whole different answer. I have a set of numbers, actually an infinite set of numbers that I could use as a solution. Because now not only can x be 4, it could be any number less than 4, okay? Which means if 0's here, 3 will work, 2 will work, negative 100 will work. What do I mean will work? I mean if you take this number and you plug it back in up there and you multiply it by 5, your product will be less than or equal to 20 as long as you solved it right. So if I did 5 times the, let's say 2, 2 is less than or equal to 4. You're telling me 2 is in your solution set, so it should be less than or equal to 20. Is 10 less than or equal to 20? Yep, that's how you know 2 is your solution set. What would happen if I picked a number that wasn't less than or equal to 4? Like 5. And I did 5 times 5, and I got 25. Is that true? Shh. Okay? So we understand what makes it true and false. If you plug it in and it's true or false. Got it? Okay? So if I were to take this problem and say, all right, that's what a multiplication problem looks like. Let's take this problem and say negative 3x is less than or equal to 12. Okay? So I am about to do something. For those of you who know what the little spin on multiplication and division is, you're going to like do a silent gasp when I solve this problem because I'm going to do it wrong. But wait. Okay? So there is something that goes down with multiplication and division that I cannot stress enough. It doesn't happen in addition subtraction. So if you're half listening, you're going to probably get it wrong. So you're going about your merry way. You're half paying attention. Oh my gosh, I hate doing this. And you're like, why? What's the big deal? Because I didn't do anything different than I did up here. I divided by 5. I recopied it. All right, you're wrong right now. You just don't know it. Okay, we're going to find out why. You're going to graph your solution set. 0's over here this time. You're going to color in 4. You're going to probably shade it to the left, and you're going to get it wrong. Why? Because here's the deal, and I'll get back to you 1 second, Kate. So you're telling me that when you solved this, your answer can be any number less than or equal to negative 4. All right, then, pick a number that's less than or equal to 4, put it in for x and see what happens. Oh. So is negative 3 times negative 5, which you're telling me is your solution, is positive 15 less than or equal to 12? Not last time I checked. It's actually greater than. But you're kind of confused because you're like, I didn't do anything different. Yeah, there was something different about the problem. Right off the bat, what does this problem contain that this doesn't? A negative. And it contains, and actually more than that, what was the act of what I did? I actually divided by a negative. How many of you remember this rule from last year? So how can I fix this? What could I do? One quick, easy fix could make this inequality true. If I just did what with that? If I just flip that around, thank you. If you leave the 15, leave the 12 and flipped it to make it a greater than instead of a less than, wouldn't that be true? Yeah. So what you're telling me is this isn't true, but if I rewrote it and instead of making it a less than, made it the other way, it would be true? Yes. So my solution set isn't really less than or equal to. It's greater than or equal to. Let's see if that works. What is a number greater than or equal to -4?
-2.
-2. Let's put -2 right there. And see if that is less than or equal to 12. And it sure is. So flipping that inequality sign around fixed it for us. Yeah, you want to know why? Because negatives mean the opposite of. And when you multiply or divide by a negative, if you don't remember to flip that, then you're going to get half of the problems on every assessment that you do wrong. Okay? One little thing that you need to make sure you remember. Okay? Which then means, actually, let's do a little quick summary, and then I'll show you how it applies to division. Actually, I'm going to show you this example. There are examples of kids all over that half listen. Do you know what that means? That you think you can put like one ear doing this and one ear doing that. And this is an example of a kid who is half listening. They're going on their merry way. And then I'm like, what? Normally, my problem is kids don't flip it when they're supposed to. This person flipped it when they weren't supposed to. But their response to me was, well, you said if there's a negative in the problem to flip it. And I say, no, I did not. I did not say if there's a negative in the problem. I said what? If you multiply or divide by a negative, flip it. I divided by a positive. So that's called half listening. So let's write down exactly when to flip it. When you do one of these two things, either multiply or divide by a negative number, comma, you must, and we say flip it, I say switch the direction, sounds a little more, you must switch the direction of the inequality, okay? Sign. Okay? So now we have a very specific set of rules that we need to follow, which means we need to be on, like, you know, when you solve those addition and subtraction ones, you probably could do them like half asleep. You probably could half watch TV and half do those because there was nothing fancy about them. You have got to give every problem your full attention now because you got to be on high alert. Oh gosh, do I flip it or not? Okay? So like if I have -2/3 x is greater than 8, what am I about to do? To solve this problem, I have to do what? Multiply by the reciprocal. And what is the reciprocal of a -2/3?
-3.
Good. A -3/2. I didn't ask for the opposite. Opposite and reciprocals are different. You know that. So to solve this equation, I multiply everything by that, which means I'm about to multiply a whole number by a proper fraction, improper rather. So I'm going to put that over 1. And then I just kind of hope it cross cancels and gives me an easy answer. In this case, it does. This goes in here. But 4 times -3 is -12. But look what I have to do with my answer. It's no longer greater than because of what I just did. It's less than. And my answer is that. And you could tell if you're right by picking a value in the solution set that you think is true. And if it is, you're good. And if it isn't, you're not. Okay? So being able to check your answers is very helpful. Okay? So let's talk about a common mistake here. Let's look at how this looks like in division. The rule is the same. It just looks a little different. So I'm thinking of a number. I divide that number by -8, and it has to be less than or equal to 5. So what are the values of a that I could put right here, divided by -8, and have a quotient less than or equal to 5? Okay? So I'm going to multiply both sides, right? By what? By -8, because that's what you want gone, right? So after my -8's cancel, I have a is now greater than or equal to. If you're going quickly, you're going to miss this. And every year, no matter how much I stress it, kids miss it all the time. Please don't let that be you. Okay? Which means if I think of a number greater than or equal to -40, so like -39, it's going to be ugly, but I'm going to put -39 right there. I'm going to divide it by -8. I'm going to get -4 point something, which is that, or positive 4 point something. Is positive 4 point something less than or equal to 5? Sure is. It checks. Okay? So let me show you this. What if I chose -40? What if I put -40 there? What if I said is -40 divided by -8 less than or equal to 5? This case, it's true. But what if this wasn't there? Is 5 less than 5? No. So this would be a check, which would be okay, and this would not. This would be, there's a no solution there, okay? So this is the most important part of this right here, okay? So let me show you one more example. So we had our verbal models for addition and subtraction. We got to do some verbal models for multiplication and division now. So if I were to say the product of a number, we'll call that number M, and -3 is at least 12, you got to take this all the way through that cycle. Take it from the verbal to the problem to the answer to the graph. Okay? So let's take it from words to your actual, what the problem would look like, to the answer to that inequality, to the graph of that inequality. You ready? First of all, I have to remember what product means. Is that multiplication or division? Product means times. So the product of M and -3, you don't get to write like this anymore. I know that's the product of M and -3, but this is advanced algebra. We don't write it that way. We write it how? -3M, right? So here is my -3M. Is at least. So this is going to be the smallest it can be. So if at least means what? Greater than or equal to 12. And then I'm about to divide by a negative. And when I divide by a negative, I flip the direction and I get -4. Got it? And then I would take that and graph it, okay? Now, I have to point something super crazy important out to you, because it's another one of those things that if you don't stop and think about it, you're going to do something and then undo it without even realizing you undid it. What am I talking about? Let me show you. If I were to take -30 is greater than or equal to -3x, all right? If this was -30 equaled -3x, you probably wouldn't even think twice about just going, oh, x equals 10, and putting the x on the left instead, right? You shouldn't, because there's nothing you even have to double think here. But what would happen if I divided by a -3, and then I just decided, I know I needed to flip it, right? So you go, oh, I got to flip this and make it that way. But I don't like my x on the right. I want it on the left. Well, you just flipped it, and by flipping the x, you unflipped it. Watch what I mean by that. If your variable's on the right and you have to flip it, it's a double whammy. This is what I would recommend doing. Keep it like this for now. Flip this inequality sign. Keep the x there. And now put your x on the left if that's where you really want it to graph it. And that's different, isn't it? So just putting the x from here to here in an equation, big deal. But if you have the x on the right and you decide you want it over here and you flip it, you flipped it and unflipped it in the same exact step. And your graph is going to be backwards. So when it's on the right, just solve it as is and then move it later if you need to. Got it? Okay. So then all I have to show you then is a quick inequality or application problem. All right? So let's say that it's fall, leaves are falling. You want to walk around and rake some lawns, right? I got kids who come to my house and say, I'll rake your lawn if you pay me $12. So you're going to go out and rake some lawns, and you're going to charge each person $12 per lawn, okay? Because you're saving up for a skateboard, and that skateboard is $188, okay? That's your goal. So when your goal is to raise at least a certain amount, I really don't want to use equals because what's the harm in earning more than $188? I've never heard anybody say, "Ooh, I'm going to raise $188 and as soon as I get to $180, I'm going to stop." Why? Keep going, right? Okay? So the question is, be careful. I'm not going to phrase it as how many lawns do you need to rake to earn your money. I'm going to say give the possible combinations of lawns or the possible number of lawns. So give all the possible number of lawns that you could rake and still meet your goal. Possible number of lawns means it can be more than 188 or it can be more than whatever your number is. Okay? Give the possible number of lawns you can rake and meet your goal, your money goal. So I know what you're thinking. You say, well, so all I have to do is divide 188 by 12. Yeah, and I'll get my answer. Yeah.
Does it mean when it says give possible number of like,
As an inequality, yeah.
yeah, but does it mean like you have to graph it without saying graph it?
No, that's actually because your answer as an inequality will give you those possibilities with that. So the inequality and the graph are just two different ways to show the same thing. That's good though. Okay, so you said, well, I know I got to divide, which if I divided to get my answer, then what did I do to start out at what kind of equation? An addition or a multiplication. So if we're looking for the number of lawns, why don't use 12L? Does 12L represent your total amount you're going to get paid? Yeah. Because if somebody said at the end of the day you raked 6 lawns, then all you would do is multiply, plug in 6 for L, you made $72. Oops, you need 188. Keep going. Get back out there tomorrow. Okay? So the number of lawns that I rake needs to be greater than or equal to $188. That's the inequality rather that I'm looking for. Yeah, I mean, you could put equals, but when it says give the possible number of lawns, because could you rake 100 lawns and still meet your goal? Yeah, I don't want only that. So when you divide by 12, by the way, I'm dividing by a positive, so nothing is switching. This pops up in my calculator. 15.6 repeating. And because this is an application problem, it's requiring you to think. So if you put 15.6, you're not going to get it wrong. You're just not going to get your 4 because you're not thinking. Because if somebody comes to my house and says, can I rake half your lawn, lady? And leave like a perfectly green grass and then the rest with full of leaves, I'm going to say, get out of here. You can't rake a half a lawn, right? So then what should I make that number? Now the next question is it 15 or 16? It's got to be 16. Because if you bump it down to 15, then you only make $180. So the answer to earn you your application credit is the number of lawns you really need to rake. Has to be not what popped up on the calculator, but what answer makes sense in terms of the problem. Okay? Got it? So when you multiply or divide by a negative, what are you going to do? Flip the direction of the